All right, so we're going to talk about how to solve quadratic equations today. So we're going to start just by solving a linear equation. This is something that you guys have done a lot of. So go ahead and pause the video for a second and solve that equation. All right, usually what our strategy is we're trying to get x by itself. So if you look down here, if I've got, I want to get x by itself, I could add the 2 over. That would be 0. So now I have 3x equals 7 plus 2 is 9. It's 3 times x, so I'm going to divide by 3. Right, the inverse of timesing. So that's 1x, or x. I have to divide the other side by 3. So we get our solution. What that really means, right, if I've solved for x, is if I put x back up in my equation, it should make the equation work. So if I have 3 times 3 minus 2 equals 7. Let's see, 3 times 3 is 9. 9 minus 2 is 7. It checks off. And you guys have been solving equations like that for a long time. Now this is what we're going to work on. This is what we call a linear equation. If you remember when we talked about polynomials, if my degree is 1, my highest power is 1, it's considered to be linear. If I look now at a quadratic equation, something like this, x squared plus 5x plus 6 equals 0. Okay, and it's quadratic because the highest power is 2, it's degree 2. We can't solve this the same way, and the reason why is because I have an x squared here and an x here, there's no way for me to get x by itself, like over here, right? You want to say I want to get x by itself. Well, the problem is, if I get that x squared by itself, I'm going to have that other x in there. So we can't solve this the same way we've solved other equations. So we've got to look at some different strategies, and that's what we're going to do today. Is we're going to talk about one strategy as solving quadratics. So if you want to put this is our learning goal, right? Solving polynomial equations by factoring. When I say polynomial, we're going to focus specifically on quadratics, which is one type of polynomial, right? Okay, and again, quadratics is when my highest power is 2. All right, so this way of solving is based off of this really simple idea. So I want you to look at this. If I tell you that a times b is equal to 0, I want you to think about, what does that tell me about a or b? So pause the video, think about that for a second, unpause it when you think you've got it. Well, if a times b equals 0, right, that means either a has to be equal to 0 or b has to equal 0. Right? 0 times anything equals 0. So that seems really simple, but the way we're going to apply that is, if I have, go back up to that example I have up above. If I have a quadratic equation, x squared plus 5x plus 6 is equal to 0. If I want to solve that, if I could write this part as being something times something, like the a times b, then I could just set each of those factors equal to 0. Well, and we know how to do that. That's just factoring, right? I'm going to say, what can I multiply together to get the x squared plus 5x plus 6? Well, let's see. There's got to be an x and an x there, right? And then it's got to be something times something equals 6. That adds up to be 5. That'd be 2 and 3. So now I have something times something equals 0. It's just like that a times b equals 0. Well, that means either the first factor, either the x plus 2 has to equal 0, or the second factor, the x plus 3 has to equal 0. Well, we could find out when x plus 2 equals 0, right? Just solve that equation. I'm just going to minus the 2 over. So x equals negative 2 is one solution to that equation. Or I could minus the 3 over, and x equals negative 3 would be another solution to that equation. Let's try it really quick and make sure they both work. If I plug negative 2 back in, I have negative 2 squared plus 5 times negative 2 plus 6. And the question is, does it equal 0? Well, that'd be 4 plus negative 10 plus 6. And that does equal 0. You could do the same thing with negative 3. It also works. So one strategy for solving a quadratic equation is if I can write it in factored form. If I can write it in factored form, I can use this. This is called the zero product property, where if I have two things multiplied together to equal 0, either the first one has to equal 0 or the second one has to equal 0. So if I can write it as being something times something equals 0, either the first one has to equal 0 or the second one has to equal 0. So let's look at some examples of this. In a minute here, I'll actually write down some steps that we'll go through. So this is that zero product property we just talked about, right? It says if the product of two real numbers is zero, then at least one of them has to equal zero, right? If A times B equals zero, then either A has to equal zero or B has to equal zero. Okay, so if you look at these equations, these are already factored for us. So, in the back of my head, I'm focused on this, hey, A times B equals zero, either A has to equal zero or B has to equal zero. So if I come down to this equation, I got to make sure it's equal to zero, which it is. And then just look at your two factors. I have a factor of 2x and a factor of x minus 4. Well, if I multiply those two together and get zero, that means either the first one has to equal zero or the second one has to equal zero. And if I can solve those two equations, I have the solution to that equation up above. So I'm going to divide by 2, x equals 0, add the 4 over, so x could also equal 4. Hey, let's try that. If I plug it back in, I'd get 2 times 0 times x minus 0. Sorry, let me try that again. Sorry. But if I plug 0 in, I get 2 times 0 times by 0 minus 4. So 2 times 0, 0. 0 times negative 4. Does that equal 0? Sure does. Try plugging 4 in. 2 times 4 times 4 minus 4. The question is, that equals 0? Well, 2 times 4 is 8. 4 minus 4 is 0. That definitely equals 0, so it also checks off. So my answer is 0 and 4. Sometimes you might see it written this way, as we call this a solution set. It's just the set of all the numbers that are solutions to my equations. You may see those squiggly brackets like that. You can also write it that way. Either one of those two would be great. Okay, let's look at this example B. So again, this one is already factored. I have x minus 3 times x minus 9 equals 0. So I'm going to go set each of those equal to 0 and just solve them. This would be x equals 3. Add the 9 over, that would be x equals 9. Okay, those are the solutions to that equation. Now, usually your equation won't already be factored for you like that. So if you look down at, let's get past those. Oh, we have a lot of them that are already factored. But if you look at, for example, this example number 8 right here, I have a squared plus 5a equals 0. Okay, these are going to be the steps we're going to follow. I'll write some steps down. The first thing is we want to make sure the equation is in standard form, which means everything is on one side and 0 is on the opposite side. So if you look at this example 8 right here, it's already in standard form. I've got the a squared plus 5a equals 0. Okay, so make sure it's in that standard form. The second step is to factor. Let's go back up to that example 8 and factor it. Well, I could take a common factor out of both of those. I could factor out an a. So I had an a times a plus 5. Okay, step number 3 is you set each factor equal to 0 and then solve. You solve each of those equations you end up with. So in this case, my two factors, one is a and one is a plus 5. I'm going to set them both equal to 0. So I'm going to go a equals 0 and a plus 5 equals 0. And I solve those two equations. Well, this one is already solved. This one I can minus the 5 over, right? So a is equal to negative 5 and a is equal to 0. So my solution set would be negative 5 and 0. Those are the two solutions to my equation. Let's try this middle one right here. Actually, let's try number 10 over here. I'm going to rewrite it. I'm just going to squeeze it in here. The 4x squared equals 2x. All right, so if I follow these steps, I want it to be in standard form. I want it to be equal to 0. So I'm going to move that 2x over. So I end up with 4x squared, and I'm going to minus it over. Right? I have to minus 2x from this side, minus 2x from that side. Now I can't combine those, so I just have 4x squared minus 2x equals 0. Okay, so I got it in standard form. Okay, now second step is to factor it. So I can take a 2x out of both of those. If I take out a 2x, I'd be left with 2x minus 1. The next step is to set each of those factors equal to 0. So I'm going to go 2x equals 0. and 2x minus 1 equals 0. So solve this one, I'm going to divide by 2. 0 divided by 2 is still 0. This one I have to add the 1 over 2x equals 1 divided by 2. So x is equal to a half. That's my solution set. 0, so it's supposed to be those set notation, 0 and a half. Okay, so if you follow those 3 steps, that will get you there. So get it in standard form. This is really important, guys. It has to be equal to 0 if you want to put a little star by that. Before you can solve by factoring, one side of your equation has to be equal to 0. Then you factor it, set your factors equal to 0, and solve. Okay, let's try this one right here. So I've got p squared minus p minus 30 equals 0. So start out first, right? I need it equal to 0, which it is. Like it's already equal to 0. That part's done. Second step is to factor it. So let's see if we can factor this. So just think backwards, right? I know it's got to be p times p to get me the p squared. When I times the other two, I get negative 30. So I could have negative 1 and 30, negative 2 and 15, negative 3 and 10, oh, negative 5 and 6. And I want the ones that add up to be a negative 1. Well, those two add up to be a positive 1. So if I switch the signs and make this a minus 6 and a plus 5. Right, when I times those, I get negative 30. I add them up, I get negative 1. Okay, now I just set each of those equal to 0. So p minus 6 equals 0, and p plus 5 equals 0. So this one I'd add the 6 over. This one I'd minus the 5 over. So my solution set, right, would be positive 6 and negative 5. Those are the two solutions to my equation. Now I'm going to skip past that one. I want to get to one that's not in standard form already. Let's actually do this one first, though. So let's go ahead and solve this. So step number 1 is you want it equal to 0, which it is. Step number 2 is to factor n squared minus 9. Hey, this is one of those difference of squares, right? I can write that as being n squared minus 3 squared. So a factor is to be n minus 3 times n plus 3. Okay, set them both equal to 0. N minus 3 equals 0. That's my first factor. My second factor is n plus 3. So n equals 3, and n equals negative 3. So negative 3, positive 3 are my two answers. Let's get to one where it's not already in standard form. Now let's try this one right here. So I've got n squared minus 20 equals n. So I want it in that standard form. I want my equation to look like this, where it's the squared term comes first, then the x term, so bx. Let me just fix that, sorry. The x term comes next, the constant comes, then equals 0. I want it to look like that. So this n is on the wrong side, so I want to move it over. So I'm going to minus n from this side, need a minus n from that side. So this would be 0. That's what we wanted. Over here I have n squared. I can't combine the n with an n squared. They're not like terms. So it's just minus n minus 20. And I put the minus n in the middle, right? Because I want it to be in that standard form. I want the quadratic term, the linear term, the constant term. Okay, my next step is to factor. So let's factor that. So I know it's got to be an n and an n. I need the factors of negative 20 that add up to be negative 1 right there. So let's see, negative 5, positive 4. So this would be minus 5 plus 4. Okay, last step is you take each of those factors and set it equal to 0. So n minus 5 equals 0, and n plus 4 equals 0. So I'm going to add the 5 over. I'm going to minus the 4 over. So my solution set is positive 5 and negative 4 are my two answers. Really the hardest part about these problems usually is the factoring. Like the factoring can get tricky. Let's find one that has some tricky factoring. This one, actually the factoring is not tricky, but let's do it anyway. So I want to put this in standard form. It's really hard to factor if your x squared term is negative. So even though it looks easy just to move that over to that side, we don't want to do that because the x squared is already positive. So what I'm going to do instead is take the 5x and the 4 and move it over to this side. So I'm going to add the 5x over, and I'm going to add the 4 over. Right? Those would come out to be 0. So I end up with x squared plus 5x plus 4, whoops, kind of out of line there, is equal to 0. This is a pretty easy one to factor, but I just wanted to show you another example of putting it in standard form. So 2 sets of parentheses, x and x, factors of 4 that adds up to be 5 would just be 4 and 1. Set those equal to 0. So we get negative 4 and negative 1. All right, let me find one here where the factoring is a little harder. Oh, here we go. Okay, let's try this one. So I've got 14r squared plus 13r minus 12 equals 0. So the first step is done. It is equal to 0, which is great. But I do need to factor this. And this one's trickier because of the 14, right? So I'm going to do my 2 sets of parentheses. I'll see, let's just do the factoring part. It could be 14r and r, but it could also be 7r and 2r. And then I need the factors of negative 12. Negative 1 and 12, negative 2 and 6. And now we're going to go through that whole guess and check process and see if we can come up with this. I think the one that might work, let's try it. Let's try the 3 and the 4 down here. I think it's either plus or minus 4. And I'm not sure if those signs are right, but we'll try it. So I times the outside 2 minus 21r. The inside 2 is 8r. Okay, that adds up to be a negative 13r. So if I just took those and switched the signs around, see, I'm going to make that a minus and a plus. Okay, now I get 21r minus 8r. Combine those, that gives you the 13r. So just remember all our good factoring stuff, and that's what usually the most time-consuming part of this, solving one of these, is the factoring. Okay, now I just set those both equal to 0. Now, up until now, this part's already been by itself, so all we had to do is add the 4 over. The answer was positive 4. But now I've got to solve for r, so I've got to get rid of the 7 also. So I'm going to add the 4 over. So 7r equals 4, and divide by 7. So r equals 4/7. This one I've got a minus of 3 over. And divide by 2. So r equals negative 3/2. So my two solutions are 4/7 and negative 3/2. So that can get a little bit tricky, but again, the tricky part's the factoring. That's the most time-consuming part. If we know how to factor, then these are not too bad. Okay, so if we go way back up there to our steps, those are the steps we're going to follow, right? Somewhere up here. Whoops, went too far. Oh, there they are, sorry. So number 1, get it in that standard form. Number 2 is the factor, and this usually is where you're going to spend most of your time. Lucky for us, we're really good at factoring, right? We've practiced that a lot. Okay, then the last step is you set each of the factors equal to 0 and you solve from there. Okay? And that's how you solve